Welcome to STARS Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to STARS Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. My name is Susan Wise. I am your host, and we are joined with Dr. Gary Stutte, horticulturist, plant physiologist, plant biologist, space biologist, or as he says, space farmer, and founder and CEO of SyNRGE. Welcome to the show.
Oh, well, thank you very much. It's a pleasure to be invited and have a little chat today.
I like the sound of a space farmer. I get that. We're going to be growing things in space, right?
That is absolutely what the goal is. We need to stay alive out there. We need to eat. And as we go beyond Earth, we need the tools and technologies to feed ourselves as we begin exploring this vast unknown in an inhospitable world. So that's what we try and do.
What is SyNRGE? This has to do with all of the space farming?
Right. Yes. Well, my background is I'm a horticulturist, and I worked for like 25 years on controlled environment agriculture at Kennedy Space Center, trying to find and identify the tools and technologies for keeping people alive on the moon and Mars. And then roughly 10 years ago, I began looking around saying there's so much technology that times are opportunities for commercial flight and the beginnings of the democratization, if you will, of access to space. Mm-hmm. That how can we take this technology to use for growing plants in space to using that and applying on Earth? And how do we take the innovative technologies on Earth and look at as we go beyond? So SyNRGE comes from the name of a first of 3 spaceflight experiments I led, looking at plant microbe interactions on the International Space Stations. So we have plants that are growing to get the food and our air and our water purification, then the microbes. How do they work together to convert to space? How do we can maintain balance and synergy in this inhospitable world? So SyNRGE came out of that as a research and development and a consulting company.
Great. So what are you currently working on to further the space industry? What's going on?
We've got a couple of things that we work on coming out of our own work from those space experiments were microbes that once we took them, these beneficial microorganisms that make a plant better than it is, they form these symbioses. One talks to the other, and they make plants grow better. They have more nutrients uptake. They improve stress. So we've been working to convert that to a commercial product here on Earth. And then alternately, similarly to that, are using microbes to break down waste material coming from humans. Think number 1 and number 2. And we're going to take those, to extract the nutrients, and recycle those back so the plants can be used on. So we can begin looking at a bioregenerative life support systems. How do we use our waste streams to get the nutrients so we get a continuous, sustainable life support system on the moon and Mars? Those are 2 we're very actively working right now.
Now, when you say we're using our waste, explain that a little further.
Okay, so there are humans or messy
Are you
little
talking about
people.
human waste?
I'm talking about pee and poop is what I'm talking about. I'm talking about garbage, pee and poop. That is what we're taking. We're running them through reactors, taking the nutrients out, and using the fertilizers that were the basis for all of agricultural development for millennia. And we're going to take these tools, we're going to take those with us so we can survive here on the moon and Mars. We're not just going to jettison it away because it's expensive to replace. Took a lot of effort.
It wasn't just a movie, right? This is real life.
This is real life. This is real life. While working out at the Kennedy Space Center, myself was a part of a support team, and we led a number of experiments, actually growing potatoes for long
Mhm.
duration space missions. We began using waste material or shower water, uh, recycling and purifying urine, fecal material to get the nutrients out so you could recycle and sustain. So, no, the movie was, it got all the details wrong, but the big things were right.
Okay, okay, that's good. Now, so I've got to do something to help my basil and my rosemary because their microbes are not talking to each other right now very well. But anyway, that's for
Ah,
another
that's a,
day.
that's a whole nother day. But basil and rosemary, now that you bring them up, are very good as we start thinking just about food and potato nutrients. But those also have, you get flavor, they have nutraceuticals. So that's the opportunity to use these technologies for hydroponics. They give us food, flavor, medicinal plants that we can take with us as we go here beyond Earth into low Earth orbit into outer space. How do we
That's so cool.
how do we feed ourselves
Hmm.
with the limits that are presented?
Gary, what has been one of your biggest aha moments? You just went, yes, I
Yeah,
got it, or I figured it out.
there have been a lot, but I think the very first aha moment was what really brought me into this business, if you will. My background is as a horticulturalist. I was working on the faculty of apples, peaches, plums, and pears, figuring out how we're going to get fruit trees and keep them healthy. And I came down and visited uh, this program called the Controlled Ecological Life Support Systems here at Kennedy Space Center many years ago. It's defunded and doesn't exist anymore. But what it was able to do was track like carbon dioxide, oxygen, water very minutely. And that was recycling the air and the water. And in that moment, it was that, aha, this is all related. We are in a closed system. There's no such thing as a waste product. We just have resources we're not using. We began using our waste CO2,
Yep.
using the plants to convert that to oxygen. We're taking our pee. The plants are converting that to fresh water, taking the nutrients out. We can recycle. So I can drink that glass of water for the next 3 years. And in the process, I'm producing food. And so that closed system was a real aha that it's possible to do this. We can try and get it. The next aha moment came roughly before I started SyNRGE. I have been saying very long time, these are things that can be applied here on Earth. How can we use these in different places and cities and places without water, tough climates? So I began to test that, and I began traveling consciously to places in inner cities, in deserts, in urban areas, and cold areas. What would work and what wouldn't? And it was, yes, we can take this technology that we have been working for decades to grow plants on the moon are not being applied as clearly here on Earth. And so we began applying that, which is why we got SyNRGE. And that's what we try and do. Take those technologies from space, apply to Earth, and the best ones on Earth apply to space.
Gary, what has been your biggest challenge and how did you overcome it?
Um, Probably the largest challenge is the whole idea that plants are necessary to keep one alive on long duration missions, that exploring space is something other than rockets, and that we're working in an environment that has thousands of engineers and maybe 24 biologists. And so it's like we can use these. I don't need a gas tank. I'm not wearing a backup tank today just because photosynthesis didn't work this morning. How do we make that case that biology is important, that it's a critical idea, not just a nice to have and a nice visual for connecting, but it's truly an integral part of that system. And what's been helpful on that is as our work of figuring out how to do that, how to get the light, the CO2 and controls has really resulted, in my view, the seminal work that's allowed a whole new industries here on Earth to develop. Indoor agriculture, where they're doing vertical farming, was not possible before we came up with these LED lights, these low intensity lights we all use, are enabling the industry of indoor agriculture, indoor farming, vertical farming. We were some of the first to do that, but the necessities to get to the moon, to Mars and beyond. So that challenge of communicating is difficult. So how do we get around that? We talk a lot. We relate those to small systems. We show how that can work. And currently on the International Space Station, they've been growing food, eating their food they're growing, tomatoes and lettuce and peppers for almost a decade now.
Fascinating. I have a kind of a odd question. This is something that
Go
my
ahead.
dad told me, and I don't know if this is true, but he tried to tell me that when farmers are farming, say they're growing a crop today on
Right.
this land, that soil is not as nutrient rich as it was, say, 40 or 50 years ago. Is that true?
Um, it depends on where you're at and how the soil has been treated. I'd say generally, yes, because what would happen is if you've got a monoculture and I'm from Oklahoma and the plains of Oklahoma, and there's lots of large agriculture.
Hmm.
It is a monoculture. It's harvested, and those resources are taken off and taken off. So you're mining out the nutrients. And then when the fertilizer is put back in, it's a different mix. There's also efforts to prevent pests and weeds, which to maintain these high yields.
Hmm.
But that challenges the microbial communities in the soils and the nutrient balance, which is very much what SyNRGE had been working on as we go to space. How can we get microbes in the root system to maintain a robust balance, to get the nutrients so we can sustain and recycle? So unfortunately, yes, there has been a decline in different places. Our goal is try and build up things through lunar regolith, what we call dirt on the moon or Mars, which will not support plant growth, but we can use these microbes to make that happen. So how do we build a sustainable system to stay alive as we leave Earth and go to the moon and Mars?
Amazing. Do you have a piece of advice that you'd like to share with our listeners?
I'm going to give two pieces of information and a piece of advice. One
Okay.
is, I think in my lifetime, two things are going to happen. One is that there is going to be another 2 billion people on this planet. That's the population of North and South America, parts of Africa, and Japan, who are all coming to dinner. And we've got to figure out how to feed them. And that's going to challenge how we relate to each other as human beings. And we're seeing many of those challenges now in our current time. But we're also going to land on the moon and then on to Mars. And that is going to challenge us. And we're going to be no longer a single planetary species. So we must continue to look up and dream and vision, but not forget what we're doing here on Earth. And continue that polarity, looking up, but working well here on the ground. And amazing things can happen.
Very wise words. Before we wrap up, Gary, do you have any passion project, maybe past or present, that you'd like to mention?
Oh, I'm so glad you asked. Absolutely. I'm just starting one. I
Oh,
have just started one, And it is, I have some property in North Carolina that was formerly an old school. It was founded in like 1904. It had burnt down, but I've got the land in those ruins. And so I've recently started a not-for-profit called the Old Tulsa School Research and Education Center. And that's objective is going to be taking these tools of sustainability of the past, of medicinal plants, looking at how we apply those now in hydroponic and sustainable agricultural practices and directly apply those to space agriculture. So bridging that link between where the past into the future. So that was registered 2 weeks ago. We're looking forward, doing updates through my other websites and communications. So we can do very much what I think your goal is here, to excite the next generation.
Yes.
To solve the problems that we're going to be leaving them. I feel some guilt about that, so I want to give them a tool to somehow deal with these issues.
That's great. Thank you so much, Gary, for joining us today. Really appreciate you being on the program.
Well, thank you so much for asking and the opportunity to chat a little bit about our work.
Yes. Dr. Gary Stutte, horticulturist, plant physiologist, plant biologist, space farmer, and founder and CEO of SyNRGE. Thank you again. Be sure to join us where we connect, collaborate, and accelerate. And we'd like to invite you to join starsciences.org to receive a free 1-year membership. Enter the promo code FRIENDS321. That's FRIENDS321. And if you enjoyed this episode, please leave us a review and subscribe. And until next time, keep looking up.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube and follow us on social media. STARS Launch Pod, propelling us forward, one launch at a time.